yet.
I can hear you.
Yes. Should I wait for my team member or just
Go ahead if you want. Not an issue.
uh, okay? Um, then I'll just go.
So who you would you? Hanmin.
David Cha and Tim.
Okay. So
Yes.
team one. Do you have team name?
No, we don't have team
Okay.
name.
So let
Yes.
me call you a team one,
Okay.
and David and Hanmin. Okay. Go ahead.
Can you allow the screen sharing?
Sure. Sure. Okay.
Okay. Okay. Can you see my screen?
Yep.
Okay. Um, uh, Hello everyone. This is Hamin Lim, and I'm going to present about mini RF jammer and FM radio receiver for the CSU 310 final project. And our team members are David Cha and Dagan Kim. So for the mini RF jammer, for the difficulties, we had difficulties for finding the correct version for the GNU radio, which is 3.7.11 that we used. So there are many versions out there. It was a little hard to find which version to use. And also for the configuring and setting up correct GRC flow graph in GNU radio was also the difficulties. And for the LTE jamming, the LTE cannot be jammed due to the dual band in mobile devices that we use. So whenever one frequency is jammed, the mobile device automatically automatically use the other one. So it was difficulty for us. So maybe for the future implementation in jamming LTE connection, maybe we can set the specific range so that we can jam the signal properly. And also we can create a software to jam the LTE correctly for later. And for the demo, we created the YouTube video link. So I'll just play this for now. Uh, can you guys hear the sound?
No.
Yeah. Um, okay. How about now? Is it working?
Okay. Working. 오른쪽으로. 여기 되시면 돼.
And that was the YouTube video for us.
Okay.
And next one is FM radio receiver. As we did for the RF shimmer, we had difficulties for finding the correct version for the GNU radio, and that was the difficulty for us. And maybe for the future implementation, currently we have only implemented the receiving radio signals. One of the extensions to this project can be transmitting the radio signal by using SDR transceivers. If we have multiple transceivers, communication between two devices under a certain frequency can be done like a walkie-talkie. So maybe we can try that later. And next one is our demo video. And by that, we were able to do the FM radio receiver successfully.
Okay.
The next one is DMB receiver. So there are two different DMB standards, which are DVB-T and DVB-S. So we try to receive the DMB signal with DVB-T, but we were not able to receive the frequency properly. So I made a call to 과학기술정보통신분, which is MSIT, for the frequency of the DVB-T, just to make sure if I'm doing it correctly. So, but they changed what they said is they changed the protocol of the DMB transmission by self-development called TDMB. So therefore, we are not able to either receive the DMB or transmitting it. So maybe for the future implementation, we can research more on TDMB and receive and transmit the DMB correctly. So this is just a flow graph for DVB-T that we are working on. So we put the file source and the connect the HECRF small comb sync in here. And this was just a graph that we were to get it. And this is our end of presentation. And you guys
Okay.
can check our GitHub link in here.
Okay.
We
Excellent.
put it in here. Yes. Thank you. Any questions?
Okay. Any comment from the others? Do you have any question to the team one? So did you try the what is it? The plural SDR?
We tried the Pluto SDR, but we are not able to get the, what is it? The GNU radio flow graph GUI correctly. So
Okay.
we just used the HECR.
All right.
So we
So
were we tried using the Pluto SDR using SDR Angel and SDR console, but that one we're able to get the Pluto SDR correctly.
so if I give you a comment about the better jamming, rather than just sending a simple signal, we call the continuous wave. Then,
Yes.
but by sending a complex content, something like I can send a TV signal on that frequency, then it's easier to jamming, right? Rather than sending a very simple signal, I can send very complex like a TV, then the jamming will be much easier.
Yes.
There is the code for the 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 white space TV signal transmitter.
Hmm.
So DTV signal transmitter, and you can send it with that information. Then it is easier to encode, easier to jamming. All right. If you have any comment, there's a time to comment to team one. Anyone? All right. Thank you. You did a great job. And
Thank
for
you.
to all of you, so since we have a surging count of COVID-19 around the campus, so it's very hard to have a final exam. So I posted Lab 4, then that will replace the final exam. Okay. So good luck on the Lab 4, and there is no final exam. All right. Next team, please.
I'll go.
Oh, okay. Go.
Jaewon, you may start.
Okay.
I'll go after you then.
So Jaewon, you with the Yeon, right?
Yes, me
Do
and
you have
Yen.
team name?
Yen. No, not really.
Okay.
Can you see the screen?
Yeah, I can
The
see
slide.
your screen.
Okay.
Team
Uh,
2.
right. Tell me when to start.
Okay, go ahead.
All right. This is our presentation for the final project, mini RF jammer and FM radio receiver. Our presentations are based on most of our slides are our screenshots, and I can't go to next. Okay. First, as Hamin said, we used Pluto SDR, and it was really difficult to connect that with GNU Radio on Windows. So what we did first was we used SDR Sharp, and we were able to get the radio signal, FM radio signal, but it was really, really weak. All we hear, most of the sound was buzzing sound. We heard a little bit of music, and it was hard to set the frequency. So we decided to use GNU Radio again, and finally we kind of succeeded on finding the right version that supports Pluto SDR. It was 3.7.13, and we made it. We made the jammer with the WX GUI, but I don't know. We couldn't find out the reason, but it has unable to set BB rate runtime error every single time we did it. So we changed it to Qt GUI and find the Wi-Fi channel, get the frequency. For this slide, Android hotspot 7473 is in band 11. So when you look at the OFDM, the thing, we can check out that for the channel 11 frequency is 2.462 gigahertz. So we set the LO frequency to 2.462 gigahertz, and we played it, and we were able to successfully jam our Wi-Fi. And for LT jamming, first we had to find out our we had KT, and for KT, it used LTE band 3, and when we Googled it, its downlink was from 1805 to 1880 megahertz. So we simply changed the LO frequency to 1.805 gigahertz. But problem here was we couldn't really jam LTE because a Pluto SDR that we were given had so small bandwidth. So when we tried it with bigger SDR, bigger tool, we could see that it was working. So yeah, we tried a lot of things. We used OFDM mode, low pass filter, but nothing was working. But what we had to do was just simply change to bigger bandwidth devices. And yep, we at end it was kind of I think it was half success because we couldn't do it with Pluto SDR. Right. For FM radio receiver, we failed many times. Couldn't really get the reason. We tried many ways, but when we were successfully able to get the FM radio receiver, we used low pass filter, which filters out the high frequencies and set the cutoff frequency to 100K, and use WBM receive, which allows us to get the FM signal and set the audio decimation to 1. And rational resampler was act of changing the sampling rate and connected to audio sync, which allows us to hear the sounds. And we were successfully able to get the FM radio. We made a GUI that allows us to select the stations. The most clear ones were 95.5 and 107.7, I believe. Right, and after we will show you guys the demo, and we kind of started on DMB, but there were so little information on Google, so we'll have to research more on that. Right, thank you.
So one comment about the jamming.
Yep.
Once again, if rather than just sending a simple continuous wave, if you send the complex signal, the sources could be anything. You can stream your video, or you can convert it to the DMB signal or the digital TV signal. Then it will be much easier to jamming. I think I remember I have a digital transmitting the digital TV signal generator. I do have it. I tested about 5 years ago. Let me check my email. If I have a code, then I will share all of you. Okay, just rather than just sending a simple signal, if you try to send the complex signal, then the jamming will start work even on the LTE. Okay, so I will try to give you the code today, and you can try with it. All right.
Yep.
Okay. Good job. Any comment to the team 2? No. All right. Thank you very much. Next team, please. Janar, maybe.
Yeah. One second. Let me set up my things. Can you hear me now?
Yep.
Okay. Cool. Can you see my screen?
Yep.
Okay. Let's start.
Who you with?
Alone.
Okay.
Yes. So this is my 310 final project that encapsulates a RF jammer that jams Wi-Fi, LTE, and 3G, and FM radio receiver and DMB receiver. The team members are me and my device, USRP. So okay, let's go to the technical setup of this project. The fact that I used Windows is pretty weird because like at first I thought it was a bad idea, but then after trying compiling Junior Radio on WSL, it didn't work out. Okay, then I tried to use Ubuntu 20.04 as a dual boot on my device, but then I encountered a problem when my Ubuntu was not letting Junior Radio read the USB input-output. So then I decided to just stick with USB to Windows 10. The next thing is the GNU Radio version. I've tried using the latest 3.8 version for Windows, but for some reason it did not see my device. Then I downgraded to Haswell 3.7 version for my PC, but it also didn't work. And then I switched to 3.7.11. With the SDR, I had a lot of trouble with Adel and Pluto. The problems were simply because it was not seeing my device. So, and then I decided to switch to USRP B200, which is a bit more expensive device. And because it was listed at as a compatible device for MudMudMap. Speaking of UHD, UHD is an open source driver and API for my device for USRP that lets the GNU Radio talk to my device. And the other stuff that I used is the USRP USB drivers, and then some packages, and the NetSpot app that I'm going to mention a bit later. Okay, the first one is RF Jammer. The objective was to jam Wi-Fi, LTE, and 3G networks around me. So setting things up, to avoid causing trouble to fellow students in my dorm, I've decided to do it on my own Wi-Fi network. I've configured my Wi-Fi network to channel 1, which is 2.412 gigahertz, and then set it to bandwidth of 20 megahertz. And then I use the app called NetSpot that I've mentioned earlier to make sure that I've configured my Wi-Fi to a correct frequency. The next thing is the GNU Radio flow graphs. So the good thing about USRP is that it's powerful. It can transmit things at a maximum power of 10 to 15 decibel milliwatts, which is pretty good. So I decided to use it on full power. I used the noise source. I've added a little bit of amplitude, and then gave it to my device, and then increased the power. The maximum power, gain on USRP was 90, so I set it to 90, and then set the bandwidth to 40 megahertz, just to make sure to cover everything, even though my Wi-Fi's bandwidth was 20. So I want to show you the demo. I was not able to prepare a video, if that's fine, because I discovered that we have to make a presentation only yesterday.
Okay, don't worry about video.
Okay, but we can make a live demo.
Then is it gonna disconnect your internet connection?
No, my computer is connected through
Wire?
LAN cable.
Okay.
Yes. One second. Okay. So let me load this thing here. So here I have my phone, which is currently connected to the Wi-Fi. And I'm gonna start my USRP device. So it just loaded, and it will start jamming the network. Now it's currently loading the files into my device. And Yes, and it's live.
Okay.
So to test the network connection, I can run speed test. And yes. Yep. Okay, the next thing is Professor, can I submit the videos a little bit later?
Sure.
Okay. Okay, so next thing is 3G and LTE jamming. So setting things up. Again, to avoid causing trouble to other people, I decided to jam my own iPhone's internet connection on both 3G and 4G LTE. To know my cell network frequency, I've used something called field test node by calling this number that will give me the network's URFCN code. So I've switched to 3G, ran that code, it gave me the code. I switched to LTE, it gave me the code. The thing is that this code, I can use this code to derive my phone network's downlink and uplink frequency. So with a little bit of help from the other website, I've put these numbers and it gave me, and it's calculated me the transmitting frequency of my device. For my 3G network, it was 2,167.2 megahertz, and for my LTE, it was 954.3 megahertz. So the technique with this, it's the same as the Wi-Fi jammer. I just had to transmit noise to these frequencies with the same technique I used with Wi-Fi jammer. So here it's the same stuff. I take the noise and just transmit it to these channels. Wait 1 second. I want to show you the demo to the camera. Okay, so my 3G network frequency is 2167.2. 21 is 2167. 2167 and 2. 5. So it will now load the file into my device. Yep. So as you can see, I'm using a 3G network, but there is no connection at all. It says an error. Yep, that was the demo. Yes, and regarding KT's 4G LTE, I noticed some weird thing. I guess I think that's what you're talking about, the dual band. My phone was constantly switching between these 3 frequencies, and as soon as I would jam it, it would just switch to another frequency. I guess possible approach would be to have multiple devices jamming the phone at all these frequencies to stop the LTE. Okay, the next one is radio receiver. The objective was to receive an FM signal and play it on my computer. The first setting things up. So first, my device receives a signal from this frequency and gives it to a low pass filter, which eliminates the high frequencies from the signal, and then it gives it to this block, which then passes to a rational resampler, which basically decreases the sampling rate and gives it to an audio sync. And then we're live. So I successfully connected to KPST radio, which is a fun fact, by the way, which is one of the most powerful FM stations in Korea with 25 kilowatt power output. And here, as you can see, this one is KBS3, this one is EBS, and this one is Seoul FEBS station. I would provide the demo video files a bit later. Is that fine, Professor?
Sure.
Okay. Okay, the next one is DBM receiver. This one was a little bit more troublesome, I guess. So I have found an open source code on GitHub that like tried to transmit DVB T2 signal using SDRs 6 years ago. But guess what? That exact code is now part of GNU Radio. So I just had to go to GNU Radio's GitHub repo, download it, and then using Git, just switch the version back to 2.7 and find the example GRC files that this guy made 6 years ago. But the thing is that, so I found the example of a receiver and 2.7.11 GitHub source files and tried to run it. Unfortunately, it was not writing the file due to file permission access problems. Everything was working fine up to this level. My Windows computer would not allow Python for some reason to write the data and the impact.ts file. And then I went to the Atlas Research websites, forums, and still did not find any solution for that. So this was the error file. But however, so I just tried to disable this file sync, and I've configured the frequency to 6 megahertz. And I could see that there is a channel, and here as well. Maybe if I did not encounter this bug with the permission problems, I guess I would be able to receive, like I am receiving the signals, but it's just a problem with writing that file onto my computer. The next thing is DMB transmitter. So I looked around the source files and I found another example of DMB transmitter. So I downloaded a test sample called sample.ts. It's just 28 seconds of ocean waves footage, and I've made it to transmit it at 429 megahertz frequency. But the thing is that even though it's able to transmit a file, after a couple of seconds, my USB controller would fail to operate USRP for some reason that I don't know. I've looked at the Python error log files, but there's nothing useful for it. But at least it transmits the file for a couple of seconds, and then it just stops. So this one is 429 megahertz frequency with bandwidth. Yep. And that's it.
Okay. Any comment to the Chinor? No. All right. Thank you, everybody. Thank you, Chinor. Want to try next?
I think I'll
Roshan?
go next.
Yeah, sure. Who's with you?
Sorry.
Who's with your team?
Oh, so it's me and Ulukbek
Okay.
doing the presentation.
Do you have a team name?
No.
Okay. Can I call you Team 3?
Yeah, sure.
Okay.
So for our final presentation, Ulukbek and I worked together, and for the initial setup, we started with Ubuntu, and so we used the Adelum Pluto SDR. Initially, we tried using GNU Radio 3.8, but it didn't support Pluto SDR blocks, so we couldn't use the Pluto SDR sync or the source. So we tried to install 3.7, but 3.7 was not available for download, so we had to build it from source. And we tried building this GNU Radio 3.7 for like around 4 times, but still it failed. So we gave up on Ubuntu and we tried to go to Windows. So on Windows, we were able to find GNU Radio 3.7.13.4 that worked with Pluto SDR. And so we decided on using this for our project. So for the Wi-Fi jammer, so we created a mobile hotspot through our phone in 2.4 gigahertz frequency, and it was set at channel 1. We checked it was at channel 1, and we then generated some noise from our Pluto SDR at the same frequency, 2.4 gigahertz channel 1, so that's 2412 megahertz, and we transmitted that frequency. And since our SDR was transmitting noise that was close than the router, the phone, it overpowered the SDR, the signals from the hotspot, and our Wi-Fi got jammed. So this is the GRC flow diagram that we have. So there's this noise source, and the noise will be transmitted to the Pluto SDR and the GUI. The GUI will show us the flow chart, and the Pluto SDR sync will transmit the noise. And so this is the FFT plot. So while the Pluto SDR is transmitting the signal, and as a when we did this, our internet was not working, and when we turned the SDR off, it was working again. So the video demonstration is at the end of this presentation for all of the projects that we did. For the LTE jammer, we tried doing the same thing using like the same frequency blocking mechanism like we did for Wi-Fi, but we found that LTE, it keeps on hopping between different frequencies, and it was not like stable at one single frequency. So our STR was not able to jam the signal properly for LTE. But if we were to try this in future, we can make frequency jamming SDR, so that can keep on moving between different frequency and jam the LTE. For the FM station, so we have a receiver antenna from the SDR that receives the signal from the FM station at the given frequency. Then it will filter the noise in the signals, and it will demodulate the signal received into audio signals, and the audio signal will be passed to the speaker for playing. And so this is the GRC flow diagram. So the source will, the source is the antenna. It will capture the signal and pass it to low filter and the GUI sync. And this low pass filter will filter out excess noise and demodulate it and send it to the audio sync. And this is the result. So we were able to play the our FM station, and the video is at the end again. And for multimedia broadcasting, Um, so uh, uh, we we tried sending multimedia, but it was difficult. So we thought we will try sending text file first. So we created a text file in the desktop, and we also have like an empty receiver file, and we will transmit that file using our STR, and the file will be received, and it will keep on appending to the empty file that we have. So we did that, and it worked for text files, but for multimedia we couldn't do. So this was the GRC diagram that we used to send the file. So we had so the file source, and it was encoded and sent using the Pluto STR sync, which is the transmitter, and the Pluto STR source receives this and demodulates it, and it will append it or overwrite it to the empty file that we have in our desktop. And this worked for this worked for the text files, and this was the 50 plot that we got when we were sending and receiving the data. And now for the video presentation, the video.
So based on your slide, you're saying DMB receiving is succeed and jamming is succeed. And how about the jamming wasn't succeed?
DMB transmitting and sending. So we transmitted DMB using text file only, not the multimedia file.
Okay.
So text file sending and receiving was successful, FM radio was successful, and Wi-Fi jamming was successful.
How about LTE?
LTE, it didn't work. Like it sometimes worked, sometimes it didn't work. Like I think it was because of the frequency hopping.
Okay. All right. Thank you very much.
So this is the demonstration video also.
Okay.
To create Android host.
It is not shared.
From here you can see it's using channel 1 and frequency is 2412.
Stop share and share again. Movies.
Okay, I can see you.
This is our add-on Pluto, and this Android phone is being used to create Android hotspot. And from here you can see it's using channel 1 and frequency is 2412. And now we connecting our add-on Pluto to our computer, and now we're gonna show you how it works.
So this is the GRC file for our GNU Wi-Fi jammer. So we have a noise source that will create some noise, and we have this Pluto STR sync, that is a transmitter, and we have this GUI sync that will show us the graph plot. And since our Android hotspot that we are connected to right now, the Android hotspot is at the frequency of 2.412 because it's at channel 1. So we have set our frequency default value as 2.412 gigahertz here. And right now, if I check my internet, it is working fine, as you can see here. But now I will turn on the Wi-Fi jammer, and let's see. So the Wi-Fi jammer is on now. So I will wait for around 5 seconds and try to reload the website. So it was working before. Now if I try, it's connected. The Wi-Fi is connected to the same hotspot. So if I try here, Google.com, it does not work. It just keeps on loading. And if I reload this thing still does not work. And it's still connected to the same hotspot. And now I will turn off my jammer, and I'll stop this thing so it's not working anymore. And now I'll try to reload this. So it's connected to the same place. So if I try reloading it, It's working now. So I'll reload this page. It's working. Again, it's working. So this part is about the FM receiver. So we have our Pluto SDR source that is going to be our receiver antenna, and it will receive the FM station signals at the frequency of 97.3 megahertz. That's the FM station that we'll be tuning to today in this video. And the signal from FM station signals from this receiver antenna will be passed into low pass filter that will filter out all those excess noise, and it will also be passed to this WX GUI that will show us the graph FFT plot. After the low pass filter filters out the excess noise, it will be passed into WB-FM receiver, and this WB-FM receiver demodulates the FM signals and converts it into audio signals. And this audio signal will be passed into our audio sync, and the audio sync is going to play the audio of the FM station. So let's run this GRC file.
뛰지 않으니까.
네, 열정이 사라지는 거예요.
그럼 빨리 또 다른 곳으로 가고 싶어요.
네.
왜냐하면 새로운 것을 또 맞이하고.
So as you could hear, our FM station works. So for the last part, we tried a simplistic route. Instead of doing the digital multimedia broadcasting, which was hard, we tried to first do an easy part, which was sending a text file and receiving it. So we have a file source. It will be a text file, and it will be encoded, and it will be sent to the transmitter, and which will transmit the file. And then we have a receiver which will receive it, demodulate it, and then store it in the received file.txt. So initially in my desktop I have a send file that will be this file with text that I will be sending, and the received file is initially empty, and whatever I receive I'll append to this. So I will run my STR, and it will transmit like this, and after it is done transmitting, I'll go to the received file and see that this is the file that I received here.
How many SDRs did you have?
Just one.
Just one.
We have
then
two, but we just used one.
You just used one. Then how can you test an TX and RX at the same time?
Like it has two antennas, right? It worked like.
One is transmitting, the other is receiving?
Yeah, one is transmitting, one is receiving.
Oh, wow. Okay. All right. 오, 너무 가까워. 오른쪽에 너무 가까워. 오른쪽에 너무 가까워. 뽑으셔. 네. Okay. All right. Thank you. All right. Want to try any comment to the Roshan team? No? Okay, who want to try next?
I guess I can go again.
Okay.
Can you guys see the screen?
Yep.
All right, I'll get started. So we'll be presenting our RF jamming and FM radio receiver.
So I think you did with the other team. You try again?
Right.
Okay.
For this one we tried other setup. So
okay.
Yeah.
Jungmin and team.
So just going over briefly, the goal is to disrupt wireless connections with SDR by signaling high frequency to nearby connections. And the difficulties in this one is that the configuring environment setup was especially difficult because we tried on multiple OS and multiple GNU radio versions, and only certain GNU radio versions, 3.7.11 or 13 was working. So that took a long time to figure that out. And for future implementations, we were thinking of creating a specific zone as like no Wi-Fi zone. This way we can determine and analyze the signal levels in some areas. And the environment we used was GNU Radio 3.7.11 IIO support version, which is the same version used by Ulubek and Roshan's group, as well as using Pluto SDR and running on Windows 10 OS. And we prepared a simple video. Hi everyone, we're gonna try RF jamming using Pluto SDR on GNU Radio version 3.7.11. And the current network setting is as follows. This device is connected to Android hotspot, and it is on channel 11. And channel 11 uses 2.462 gigahertz frequency. And now, to demonstrate, right now the Wi-Fi works. We're gonna go into weather.com, and it loads properly. Now we're gonna turn on the file and try jamming it. Now this Pluto SDR is sending out a lot of signals to disconnect in this frequency network. So we're going to go into some website. As you can see, it's loading continuously and the connection was interrupted. And now we're going to turn this off again. And now we're going to go into my Gmail and or some other website, and now it loads. Thank you. All right, that was the demonstration with the Wi-Fi jammer. For LTE, we kind of noticed that it uses multiple or dual band, which has multiple frequencies that my phone uses. So we could not test it, so we skipped that one. And for the second part, FM radio receiver, the goal was to receive and process FM radio from Pluto SDR. And similar difficulties as the previous one, all the configurations with versions and the OS differences. And for this one, we just got to test this yesterday, but we could not, there were problems with our antenna, like the given one was too short to get some signals, but then the long ones that we found on a router, tried replacing, that kind of didn't work. So that's something that we'll have to solve and try again, maybe today or tomorrow. And for future implementations, we make it easy to understand how radio works so that it can be used as an educational tool. And it was used on the same environment as the previous one. And this is us trying with two router antenna, which seem not to be working. And this given one was too short to get some radio stations. And for the rest of the project, we're thinking of polishing the antenna and trying making it work, and then provide a demo video on that one and finish up our report. And that's all I have. Thank you.
All right. Thank you very much. Any comment to the team and Yujung? Jungmin? No. Who wanna try next?
Our team.
Sure. Yunshik, and who's with you?
Seungjae Kang.
Okay. Do you have a team name?
No, we don't.
Can I call you Team 5?
Yeah, sure. So for this final project, we had to prepare the laptop or desktop that can be run the OS Ubuntu 16.0.4. We have used VMware instead of installing the OS itself into the computer directly. And inside that Ubuntu 16.0.4, we had to install GNU Radio and many other updates and hardware driver for the USRP device. And for the specifically at RF jammer part, we had to use, we required the insider application for the desktop, which can which ensures what frequency that we're using for the Wi-Fi that we are actually connecting to. And the signal check is also the method that we can check our frequency that we're using on the mobile phone. So for the FM receiver, this is how we have prepared for the block section. And so how it works is this USRP source take the signals from the radio station, and low pass filter actually minimize the signals to the actual signal that we require to hear the FM radio, and WBFM receive actually take the actual frequency that is required to the radio, and after rational resampler, we actually sync that signal to the actual sound from the computer. So problems with the FM receiver is that maybe because we have used VMware to run Ubuntu OS, the sound of FM radio is not clear enough. What that means is that there's some sound break between the, we have some kind of noise between the sounds. And we had to download more data to use USLPP 210 device with Ubuntu in VMware. We couldn't just use the UHD install drivers or whatever, that the command does not work. And we had to follow other steps to fulfill that. And next part is RF jammer, and RF jammer is quite simple. It was very surprising that the actual code was quite simple. So noise type as Gaussian with the amplitude of 50, and we just out the signal and we just come into the USRP device, the signal, and it actually jams the surrounding devices. And problem with the RF jammer is that we found out that the mobile LTE has many other bands. So jamming one channel will reach your cell connecting to another channel. Searching for frequency and bandwidth is somehow difficult. So we could jam our smartphone LTE, but we cannot show you that the smartphone does not connect to the internet. But I mean, with the signal check application on your mobile phone, we could check that the band first was 7 with the frequency of 2630 megahertz. But after we jumped that frequency, we moved to the band 3 with the frequency of 1820. And we could not prepare the demo video, but we can actually show you right now. I will just stop the share screen, but please see the Seungjae Gang's screen after this. So we are actually running the radio. I'm sorry. Not sure how you're listening to it, but we can hear the sounds, but that's not really clear. If we, I just forgot to add the multiply constant with the volume control function on it. So please forgive me for some inconvenience. So actually, this is how we work with the FM receiver. And the next part will be the jamming. So we have used the VMware for FM receiver, and the jamming part we have used GNU Radio Companion, which can be installed in Windows OS. Please give us a moment for the moving up the USRP device into the system.
So if you try to show me the demo, then I will check the demo on Wednesday.
Oh, okay. Then can you just stop here or?
Okay, sure. So you succeeded with the jamming and FM radio somehow, but how about DMB?
Oh, we actually did not try the DMB.
Okay. All right.
Thank you.
Thank you.
Yep.
Anyone has comment to them? Team 5? If not, can we move on to next team? Minhang?
Oh yes, Ojin's gonna share.
Okay. Hojin and Minhang, you're two of you are team, right?
Yes.
Do you have a team name?
Oh, not particularly.
Okay. Can I call you team 6?
Yeah, sure.
Okay. Team 6, Minhang and the Hojin. Go ahead. How about Taejun? Oh, Taejun. He's not here. Okay, you are the last team. Please share the screen, please. No? Hello?
I think he has connection issues yet. He's using iPad. Could you wait for a second? Professor, sorry, could we actually go next? He's not responding.
You are the last team.
Really?
Okay, how about you visit my office and do the presentation instead of doing here? since we have
Okay.
some connection issue.
When are you gonna be in your office?
I'm not be maybe around 6 tonight
So you mean
or
that after
all day tomorrow.
373?
Yeah, all day
Okay.
tomorrow and all
Okay,
day
I'll
Wednesday.
try to visit tomorrow then. Yeah.
Okay then. All right. Thank you everybody. I think Hojin is missing. Now Hojin is there. Ho Taejun is missing today. And if you have a contact with him, please talk to him. Don't give up. And tell him I'm going to give you a chance. So please show up. Ask him to show up on the class. All right. You guys did a good job. And we officially, once again, we don't have a final exam. The Lab 4 will replace the final exam. Lab 4 won't be easy. So Lab 4 consists of the 6 labs. So on each labs, after completing your lab, you have to make a screenshot and submit your screenshot as a proof that you finished the lab. All right. Thank you very much and have a great day.
Oh,
any comments?
sir?
Yep.
For the Left4 file on the Google Class,
Mm.
it is, I don't think we can download the file properly. So
Okay.
can you just upload to AI2S site?
Sure, but I will do after 6 tonight.
Sure.
Okay, I have to be on that computer. I don't know, for some reason, only my desktop can work to have a privilege to edit the web page. Okay.
Okay.
All right. Thank you very
Professor,
much.
Professor, is 373 also online today?
373, yes, it will be online.
Oh, okay. Thank you.
All right.
Thank you.
Thank you.
Thank you.
Bye.
Thank you.
Professor.